Take a look at the try one more. Why is this problem tricky? That's right, I heard you say that this problem might be tricky because I see parts that are different sized. In the first problem, we thought about equal parts as taking up the same amount of space. For this problem, see if you can think about the size of the parts as they relate to the entire shape. Did any of you use your pattern blocks to help you figure this out? I see lots of friends saying yes, they did. Where do you see 1/4? And how do you know? Say your answers out loud. I heard you say that you used your pattern blocks and realized that if you put green triangles on top of the rhombus, like this, we will have 4 parts, 4 equal parts. So that means if you think about the shape with just triangles, there are 4 equal parts, and one of those parts is 1/4. Nice work. Great job working together to get to the answer of a tricky problem. If you look at this shape on its paper though, there are still 1, 2, 3 parts. Is it still true that this triangle or this triangle represents 1/4 of this shape? Evaluate. Why? Say your answer out loud. That's right. You have to think about the whole and the size of the parts as they relate to the whole. There are 4 parts here. You just have to look at the rhombus in a different way to see all of its parts. You have to think of the rhombus as 2 triangles. Sometimes, to identify specific unit fractions, we need to look at the number of parts and their relationship to the whole. What if I asked you to find 1/2? What if I asked you to look at this shape and find 1/2? Thinking about what we just talked about, how would you find 1/2? Say your answer out loud. That's right. We know that 2 triangles make 1 rhombus, right? So if we think about the 2 triangles in this shape as a rhombus, then we still have 2 rhombi, which means 2 equal parts that are the same size. A rhombus here and a rhombus here. 1 rhombus would represent 1/2 of the entire shape because the other rhombus is these 2 triangles. Whew, nice job. As you work with tricky shapes today and are identifying specific unit fractions, you have to think, how big is this part compared to the whole? You can also think, can I partition, that means divide, parts or group parts together to help me understand? Just like for this problem, we divided our rhombus into 2 triangles in order to see 4 equal parts. When can we use the number of parts to help us identify the unit fraction? And when do we need to think about the size of the parts? I'll say that question again. When can we use the number of parts to help us identify the unit fraction? And when do we need to think about the size of the parts? Say your answer out loud. That's exactly correct. When we have equal parts, that means our parts are the same size, we can use the number of parts to tell us the total amount of parts. Here, each of our pieces were the same size, so I could count them 1, 2, 3, 4 to figure out the total number of parts in one whole. When we have the parts that are broken into two different sizes, we can think, how big is this part in comparison to the whole?